Thank you. So I'm an internal speaker, so I'll spare you all the internal speaker jokes. I thought of a whole bunch of them. Like, yeah. It was fun talking to so many of you today, or I see so many familiar faces, this sort of thing. Yeah, they're not funny, I know. The internal speaker jokes aren't funny, that's why I'm sparing you from them. So today I'm going to talk about brand new stuff. I have this bad habit of talking about brand new stuff all the time. I like to use talks as an opportunity to get some momentum on a project that might have been simmering for some time. So Eric Dietrich is a philosopher of Binghamton. He's a philosopher of cognitive science who's done lots of work on categorization and other aspects of cognition. And we've been talking a lot about MetaPhilosophy and philosophy of science in the context of cognitive science. And he's been quite provocative in some of the things he's said and published lately. So I'm going to introduce some of these crazy ideas that Eric Dietrich has put forth just to provoke my philosophy colleagues in the room. And I would love to hear your response to him, of course. But another important reason to cover this topic today is that, of course, it fits with the theme of the MTS this year. So I am going to try to explicitly connect this to experimental philosophy. I'll talk about experimental philosophy at the end, and I'm going to argue that what I'm showcasing to you today is maybe a sort of case for data-driven philosophy, where experimental philosophy is just a subset of the possible hypotheses about philosophy and in philosophy that can be tested through the use of data. Now, before I get to that, though, I should note that the work I'm talking about today is part of a broader research context that has been emerging in the lab for the past couple of years. And the general thrust of this, even though the topics are diverse, they do orbit specific ideas, but the general thrust is that we're utilizing naturally available massive data sets to test ideas about cognition and social structure or culture. And this essentially is a turning point for the cognitive scientists in many respects. In fact, Tom Griffiths at UC Berkeley has a really interesting position paper in cognition that came out just last year about how cognitive scientists need to get on this problem of data because computer scientists they're keeping too much of it to themselves, and they already have way more than we have, and we're the ones who care about behavior. So it's a very interesting paper. But this is something that we've been doing in the lab as well. So many of you, of course, know Dave Vinson, who has been analyzing over 1 million Yelp reviews, which is kind of a crazy, fun, convenient data set that has allowed him to test ideas about language structure and language use in this sort of ecological context. And with philosophers, or with the philosopher Deborah Tollefson, who's a philosopher at the University of Memphis, and Roger Cruz, who's a psychologist at the University of Memphis, we've been using Twitter to test ideas about language use in social activities. So we've been harvesting data from Twitter to look at how people refer to and act in social contexts to see if they can be separated in philosophically and theoretically interesting ways from solo or individual contexts. So we've been analyzing hundreds of thousands of tweets, and it's a naturally available data set, it's a convenience data set, it obviously has a wide array of flaws, but you have such a massive amount of power that as long as you're aware of the flaws, and you tap in to the data set with an appropriate set of hypotheses, you can find lots of fun stuff. With Alexandra and Tini, and in a project led by Ricardo and Marcus Perlman, who many of you are familiar with, of course, I just received word like 30 minutes ago that the paper is accepted pending. So I had to update the slide, which is probably worse. Anyway, so it's accepted pending some minor revisions. We used a massive source of Twitter data through Alan Mislev, who's a computer scientist at Northeastern. And what we did, which was really fun, we time-locked second by second the ebb and flow of Twitter activity with the conversational dynamics of President Obama and Governor Romney. And what you can find is certain kinds of patterns of amplification or diminishing of tweets depending on the kind of discourse that's taking place between them. So, for example, the famous one is that when Obama or Romney interrupted each other, you saw this within 15 seconds, this direct covariation and this amplification of tweets, which is very interesting. So what we're showing is there's this interesting bridging of scales between the massive social scale and this shared experience of just an interaction between two people. We have a grant project working on, and several of you in the room have worked on, like Bodo. This is using data sets like Google Ngram and other sources of data to test ideas of language evolution. And so Google Ngram, for example, gives you, in fact, especially in English, it gives you centuries of data about vocabulary change. And we're using sources like this, along with some other methodologies, to ask questions about language evolution and also biological evolution as well. This is with Suzanne Cindy and Dave Ardell. He's in quantitative systems biology, and Suzanne Cindy's in applied math, and Gary Lupian is in psychology at Madison, Wisconsin-Madison. And finally, probably the one that's most closely related today is another collaboration with an applied mathematician, Evan Height, in our grad group, a cognitive scientist, and Evan Height's hanging out in NSF right now, of course. We're using Thomson-Reuters Web of Knowledge to develop measures of interdisciplinarity and to see if they can predict patterns of citation and attention in scientific literatures. And so we've actually had to explicitly harvest those data through programming, and we've gathered over close to 1 million authors and about 14 million articles. And what we're doing is, and Harish Bhatt in applied math is a very exciting person who can put together these really amazing algorithms that can develop interdisciplinarity scores between two people. So if I collaborate with you, how interdisciplinary are we? Does that predict patterns of citation? So the general, now I wanted to describe this because these are a diverse array of projects, but they do orbit this general idea that by using these large-scale data sets, we can ask questions that we really couldn't ask before quantitatively, namely that cultural systems are coupled to cognitive systems at different timescales, and they're actually operating always in parallel, and that we can use theories from one level to predict things about the other. And so these data sets and these kinds of projects orbit sort of cultural, social, and often linguistic domains to look at the adaptive nature of cultural processes as they are coupled to language. So, but today, we're using a different source of data. This is JSTOR. Who knows JSTOR? You guys familiar? Yeah, JSTOR, journal storage. All right, started in the 90s. Good resource, digital library. And the reason that we use JSTOR, of course, is JSTOR has excellent archiving of humanities, in fact. So there are plenty of journals that are fully represented, even for centuries, in fact, on JSTOR. And so this is in collaboration with Eric Dietrich, who's a philosopher at Binghamton. And he's fundamentally interested in the state of his field. And he's in a kind of struggle right now that, if some of you haven't seen this yet, I'm going to show you the paper, and it's provocative and interesting. And so I've had this continued correspondence with him for the past couple of years, talking about different ways in which we could use data sets to test the adaptive nature of whole academic fields. So we're using JSTOR and extracting article information about philosophy and other fields to look at the adaptive nature of those domains of knowledge. And so Eric has been struggling a little bit because he's perceiving a lack of progress in philosophy. This is how he describes it. And he laments it in emails to me frequently, especially in the domain of ethics, apparently, and metaphysics. This is what he talks frequently about. And so I think that one of the reasons it sticks in his craw so much is that philosophy still holds, in many respects, a very important conceptual position in our understanding of science and epistemological progress. And in fact, you can see some famous examples of this. Is anyone familiar with this Jerry Fodor quote? This famous Jerry Fodor quote? For example, Jerry Fodor famously proclaimed that I think many philosophers secretly harbor the view that there's something deeply conceptually wrong with cognitive science, but that a philosopher with a little training in the techniques of linguistic analysis and a free afternoon could straighten out. Something that Jerry Fodor would say. And in fact, he was talking about behaviorism, not cognitive science. But anyway, so I think Dietrich sees this sort of perceived importance, and he gets upset about it. And this is the paper he published in 2011 that prompts this collaboration between the two of us, this sort of loosely, well, yeah, here's the paper. Now this animation is for Stephanie Sheik, this pointless animation. Can you go? There you go. So according to Eric Dietrich, he gets like an email a week from a philosopher he's never met before who's angry with him. And on various paper repositories of philosophy, apparently after his paper came out, it was a top downloaded paper for a little while. But it's got a mostly sort of unwanted attention. And in this paper, he lays out his fundamental problems with what he sees as a lack of progress, which some other philosophers have been talking about as well, like David Chalmers. But he starts with a thought experiment in this paper. This is Dietrich's intuition pump. This is the Aristotle and the time-traveling vortex thought experiment. I don't know if, is this as empirical as Eric Dietrich gets? He might, right? Is it?
Yeah,
no.
not true.
Okay, so thought experiment. So the idea is that imagine there's a time machine that's invented in the future, and Aristotle can be transplanted sometime around now in the present day, approximately now. and he could speak English. That's an important part of the thought experiment. So I think he says this in the paper. And Aristotle, of course, being a person of great learning and interest, decides to wander to the nearest university so that he can catch up on the past 2,500 years or 2,600 years or whatever. So Eric Dietrich imagines Aristotle wandering the halls of a university, and he finds a physics lecture and he sits in. What he hears shocks him. A feather and an iron ball fall at the same rate in a vacuum. Being heavier doesn't mean falling faster, something he didn't quite understand. Aristotle, along with the rest of the class, has shown the external verification of this from the moon. From the moon, performed by Commander Scott, whatever, the very same equations, and how Earth stays in orbit around the sun orbit. And Eric kind of gives this playful description of other fields as well. But what happens is Aristotle finally, he reaches the end of the hallway, he wanders into metaphysics class. So you can imagine Aristotle goes in, he sits down in the metaphysics class, he's having fun using his new English skills. He says, Aristotle raises, so he's listening to this lecture in metaphysics. Aristotle raises his hand to discuss some errors that the professor seems to have made and some important distinctions he has not drawn. As the discussion proceeds, the metaphysics professor is a bit taken aback and also delighted by the somewhat older student's acumen and insight. Then Aristotle goes to an ethics class where he learns of the current importance of what is apparently called virtue ethics. He recognizes it immediately, but again, the professor seems to have left some critical details and failed to see deeper aspects of it. So this is the thought experiment, is that Aristotle would have to do all of this catching up, and he wanders into philosophy class, and so Eric says, if this thought experiment works for you, then there's a problem in philosophy. That's what he says. Even he goes more hardcore in this paper. Here's another case. Consider Einstein, Frege, and Wittgenstein. The works of the latter two philosophers are read closely to this day, not only by accomplished professional philosophers, but in graduate seminars where their works are plumbed for deep truths. Yet no physicists read Einstein's 1905 papers, even the one on special relativity, nor the 1916 paper on general relativity. Of course, both are still taught. They're regarded as the backbone of modern physics and cosmology. But what he actually said doesn't have to be fought over. And so if you believe that there's this potential distinction, now Eric hasn't collected data on this. He hasn't sort of gone out to see if this is actually the pattern that takes place. He doesn't have a time machine for which he can actually test these ideas. So the idea of this recent work is this sort of loosely adversarial collaboration. I guess I'm curious about how you might actually empirically test these ideas about academic fields using large data sets. And so what we're going to do today is look at ideas that are actually already present in some of these big data analyses about how human knowledge evolves, using analyses of keyword change, patterns of keyword change. So keywords that can be extracted from these articles are a reflection of topics that are discussed in a scientific journal in any given year. And there are obvious sort of evolutionary connotations you can attach to the way that those keywords would change. So for example, if you have a system that's establishing some adaptive responsiveness and some domain of knowledge, then you'd expect keywords to stabilize in some fashion. If you're expecting a field to be rapidly changing with lots of keyword turnovers, then you'd expect to see different kinds of dynamic profiles. And I'll show you what those profiles might look like, and we'll even analyze some. I'll show you the analysis on them. But the idea here is that these topics that are discussed in these papers stored on JSTOR serve as almost like an interesting conceptual variant that we can analyze and look at how it changes to quantify epistemological change in these scientific fields. So Dietrich actually made a prediction. Here's another. These slides end well, I promise my philosophy colleagues here. He says, I've noticed that philosophy seems to move from one keyword island to another. I've always taken this to mean that philosophy makes no progress. Think of a keyword island as a network of related words, but the network is insular. Philosophy jumps from one keyword island to another. Keyword islands resemble fads, like the hula hoop or frisbee. I wanted to copy this for Ramesh. Hula hoop. So the empirical domain in which we can actually test these ideas is sometimes referred to as a science of science or scientometrics. And it's been around for several decades, actually. The journal Scientometrics started in the 70s or something like that. But it started without a lot of computational tools that we have now. And so, for example, people like Katie Borner in Indiana, she's sort of one of the biggest, she is one of the biggest information scientists out there right now. She's done some absolutely incredible work on scientometrics. She's led a project called the UCSD Map of Science that has analyzed literally millions and millions and millions of articles and generated an interesting taxonomy of scientific knowledge. And so she's fascinating. This is her description of the different domains of scientometric research. There are different ways that you can do scientometric research to look at the structure and behavior of science. And so the one that's the longest going, the historical one, is the smallest one that she calls micro and individual. This is where you have 1 to 100 data points. Maybe you're analyzing the activity of a lab or a small community of academics or something. But what's happened in the past 10 years or so is that we now can go up to the mesoscale and the macro scale. She calls it mesoscale 101 to 10,000 records. And this is where you might analyze a network of labs or a large project or a journal. And then the macro scale is where you have 10,000 or more records. That are, now it's absolutely easy to get data of this kind, of that scale, and start conducting analysis. You can do it right now at home, in the bathroom, in minutes. It's fantastic. If you have your laptop with you. So, which happens frequently. So, of course, there's a wide array of different questions one can ask, such as developing statistical models, analyzing how systems change over time, geospatial analysis of distribution of individuals and how they share ideas, and so on. So this is Katie Borner's framework, and her work is absolutely incredible. So what I'm going to show you today is a temporal analysis, and it's a topical analysis of a very simple kind. So I really ought to note, since I'm being recorded, and this might be on YouTube, that everything I'm showing you is highly tentative. These are very preliminary analyses on complex data for which the statistical models I'm not entirely certain of them yet, but I'm going to show you some results anyway that exhibit some interesting patterns that suggest there's something really important about Katie Borner's framework. Specifically, we're going to first look at the more thorough analysis I'm going to show you is at the mesoscale, where we're going to analyze journals in these fields, all of the articles from these different journals. And then I'm going to show you very briefly a second analysis that we've just collected data on and started analyzing. And this is at the macro scale, where we have tens of thousands of articles in biological sciences, linguistics, and philosophy, so that we can compare various patterns of scientific activity, and in this case, in keyword usage in these topics. So I'm going to start with the mesoscale. So there are, of course, philosophers who are already interested in this. So Colin Allen at Indiana has actually had funded for several years this really cool project called INFO, which I think is Indiana Philosophy Ontology. And they analyze such data sets as the Stanford Encyclopedia of Philosophy, which has about 1,500 articles in it and millions of words, and developed a taxonomy, an ontology essentially, extracted an ontology. So you find a lot of their papers in computer science proceedings. But they're proposing that you can sort of data-drive philosophy to understand the relationship among different elements in philosophy and different trends in philosophy and so on. In fact, you can go to their info website and you can expand and go out from philosophy into these interesting leaves, branches and leaves of different aspects of philosophy. Andrew Higgins is, I think he just finished his PhD at Illinois, Urbana-Champaign, and he's been doing visualization philosophy, again using the Stanford Encyclopedia, but using network methods to visualize the relationship among different domains of philosophy. So aesthetics is connected to modern philosophy, which is somehow also connected to ancient medieval, and so on. So the idea is that this visualization can give you some insight into the structure and the nature of philosophy. But what Eric wants to know about is progress, how systems are changing, and whether you can attribute progress or evolution to those changes. And so an obvious way that you can do this, that I'm not going to do here, is you can look at growth of knowledge, such as how many articles are published in that field and how often they're cited and so on. And this sort of thing has actually been done in a wide variety of fields before. And in fact, it would be a relatively weak kind of proxy of progress, of course, because we're academics, everyone basically, and we sort of are wonderful at generating our own little feedback loops to make all of us interested in what we're talking about. So of course there's going to be a growth of articles and citations and so on. But there are other ways that one can do this as well. Is somebody in a separate group interested in what I'm doing? So you can look at citation patterns and interdisciplinary networks. And Andrew Higgins and his collaborator, they argue against philosophical autonomy, by the way, but they do raise this as a problem, that there has been some work in scientometrics suggesting that philosophy is indeed less interdisciplinary, and it may actually be more isolated than a lot of other fields. Higgins actually ends up arguing, as I'll show you today, that experimental philosophy represents a potential move forward to get philosophy connected in various ways with the methods and ideas from other fields as well. So Higgins' paper is actually positive, but he does cite and discuss interesting work that suggests this. But the one I'm going to talk about today is the evolution of keywords, or changing keyword usage. And this is actually based, we didn't come up with this, we based this on R. Alexander Bentley's He's an anthropologist who uses quantitative methods to study cultural systems. He has studied keyword dynamics already. He's done relatively small, micro-scale kinds of analyses of the way that keywords change over time. This is published in PLOS One, and he did a comparison of physics with, I think, psychology, actually. And what he shows is that keywords turn over rapidly in psychology, whereas in physics, the keywords he's analyzing actually end up stabilizing. And he ends up arguing for this specific perspective on those keyword data. He says that among the cases presented, the social science paradigm showed the stronger patterns of random copying with invention, including constant turnover of the keywords of highest frequency and stochastic ups and downs of individual word frequencies over time. In contrast, physical science paradigms show the rejection of the neutral model, particularly the cessation of turnover of the top keywords over time. So there's this sort of epistemological stabilization that's expressed in the frequency of the keywords that compose these articles. So this is actually, and he discusses humanities in this paper too. So he's sort of jointly arguing that the humanities and social sciences would exhibit this sort of general keyword turnover. And this is what I mean by keyword turnover that's going to motivate the analysis today. So imagine quantifying keyword preservation. So how likely is it that a keyword last year is going to be used again this year? So we can extract that keyword preservation measure, as I'll describe in a minute, and you can look at how keywords are being preserved on average over time in the scientific field. So if the field is supposedly stabilizing its knowledge, then you'd likely see keyword preservation go up. If the field is constantly creating new terms and introducing new concepts and moving from one conceptual framework to another, as Eric Dietrich might predict, then you'd get something like turnover. So here is where keyword preservation actually drops in the field in a set of keywords that you're interested in. And stabilization might look something like this. So this is not tied very systematically to any evolutionary biological ideas or anything like that. This is just an intuition that Bentley develops in the article and that we can actually test using JSTOR. So the idea today is to look at those keyword dynamics in these different fields and to see if they reflect patterns that you predict in this case. So we went to JSTOR's Data for Research service. It's completely free. You just have to send them a polite email and they'll give you access to the entire database. And the way that they throttle you is they limit you to download 30,000 articles at a time. You still have to do this extraction process and they give it to you in this really rough form, so you have to do programming and so on, but it's a very convenient resource. So what we did is we extracted all the research articles for a half century from 8 journals across 3 fields. So we're focusing on philosophy here with Eric, so we grabbed the 4 philosophy journals and 2 biology journals and 2 linguistics journals. And we chose linguistics because it's another cognitive science that we can compare to. And we asked what are the dynamics of keyword turnover. So JSTOR actually provides keywords. They're based on this algorithm that I guess their engineers run over the whole JSTOR database, which uses term frequency, inverse document frequency, which essentially allows you to identify, it's a statistical method for identifying what's special or interesting about this article. What words mark this article as interesting? So it's an automatic extraction method that has some flaws, which I'll discuss later. But you can extract keywords for any given article. You can just request them and they give them to you. So so we have approximately 10,000 articles and many tens of thousands of keywords. So here are the journals. Let's see if you like the chosen journals. Mind and the Journal of Philosophy. So in that half century, they published about 2,400 articles. And these are 8,205 unique keywords. So the actual token count is higher. This is 8,000 types. And then Philosophical Review, and Philosophy and Phenomenological Research. So these would be considered very highly ranked philosophy journals. And JSTOR has a wonderful representation of philosophy in the database. So as for biology and linguistics, we're somewhat limited with what JSTOR has. So we grabbed ones that had comparable levels of representation. We're interested in another, in another field relevant to cognitive science. So we grabbed Language, which is an older journal in linguistics, has about 1,300 articles. And then Linguistic Inquiry, which is a prominent, would you say top 5 journal? Maybe Language is the top, right? That's the, and then what's Linguistic Inquiry? 3? Anyway, it's high, right? It's high, right?
Depends on who you ask when.
Okay, yeah. And then, it was very, so I must confess, I'm not a biologist. It's tough to choose these. I mean, there are a wide variety of journals to choose from. But we chose these two because it was easy to extract a comparable article count and keyword count. And so we only, I think we grabbed maybe one or two others, but this had the best representativeness in terms of those numbers. So here's a network, just presentation of how the articles link together. There's just a random set of 1,500 of the articles. And you already see that there is indeed so this network is constructed by taking a given article and connecting it to another article if they share keywords. So you can see that these domains, cluster and linguistics and philosophy, are closer together as you would expect. Now we're not going to do any network analysis here. I'm just going to do keyword dynamics, keyword turnover dynamics. But there is the possibility to look at the way that these articles are related to each other and how these fields are structured using these kinds of spatial techniques. But I wanted to show this because it's what you'd predict with this kind of data set. So here are just some example keywords, because I'm actually not going to do item level analysis in this talk at all. Here are some example keywords from 1950 in the philosophy journals. These are highly frequent words in 1950 in philosophy. Situation, statement, principle, truth, certain, experience, logical. Example. In 1999, belief, argument, claim, moral, property, theory, truth. So I've bolded truth so that it demonstrates you have this keyword preservation from 1950 to 1999. Linguistics is the one that's most easily interpreted, I think. Here we go. Consonant, dialect, English, language, meaning, phoneme, vowel. And then 1999, remember, what's syntactic structures from Chomsky? 1957 or something like that? 1999, clause, language, lexical, object, pronoun, sentence, syntactic. So maybe you can see some flow there. So these are just example keywords from these fields. And I bolded just example keywords that have sustained over time. So what I'm analyzing, I'm actually taking the many hundreds, thousands of these keywords from these fields, and I'm looking at how from year to year, those keywords are reused in the subsequent volume in the next year of the journal. And the way we do this is, there are two measures I'm going to show you. The first one I'll call the lag profile, or the turnover lag profile. And I'm going to use a measure called the repeat ratio. It's very simple. What we do is we look at how many words are common from a previous year to the current year. And we divide that by how many words could have been repeated. So it's just a ratio of how many words survived from one year to the next. It's a very simple measure. And so turnover is actually the inverse of this, but the idea is this is a keyword preservation measure. And what the lag profile tells us is take any given article from any year, look back 10 years, how do the keywords of that year for that article look compared to the keywords from previous years? Is it more similar or less similar to the keywords from previous years? And take any given article and its keywords, what do those keywords do as you look forward in time? So if you had a field that looked like this, essentially the keywords are almost completely replaced. They're completely replaced with every year, right? So if I take an article at time 0, I compare it 10 years ago, it has nothing in common. I compare it 10 years in the future, it has nothing in common. This would be a field that has maximum turnover. This would be a field that has already stabilized in all of its terminology. And this would be a scientific field that would be exhibiting some kind of drift. It has similarity with recent years, but in fact the similarity drops off precipitously as you go beyond it. So this gives you a sense of just sort of the dynamic behavior of a given journal in aggregate, just the nature of the journal's temporal behavior over all of its years. Just looking at for any given article, you look forward 10 years and back, and how do the keywords behave. But maybe the more intuitive measure is just historical keyword turnover. So we use precisely the same measure, but we're only going to use a lag of 1. So just take keywords from this year, how many of them are preserved to the next year, in the next year. And we can look across time in a journal. So this would be a field that has a stable transmission characteristic, so it's always preserving the same proportion or ratio of keywords. Here's a field that might be stabilizing, and this would represent a field that's over these years actually diversifying its terminology. So you can see that you can almost put a kind of gloss over these patterns as a characterization of the way these different scientific fields are changing. So what's beneficial in this context, of course, and I think this is typical critique of experimental philosophy or empirical philosophy in general is that it doesn't satisfy certain kinds of normativity criteria that you have about philosophy in general, right? And so this is something that came up with Nobe last week, is that you can ask naive participants, participants who don't know anything about your task, all kinds of things and get lots of systematic responses, but may not tell you about what's actually true or interesting about the conceptual space you're exploring in the philosophical domain. But in this, and we can argue about that and so on, I agree with Nobe that polling the intuitions of individuals might actually lead to questioning the kinds of assumptions that armchair philosophy might make. But in this case, in the information sciences, we have potential normative interpretations, but they're relatively weak and they're questionable, but you can at least interpret them this way, right? So there are alternative normative interpretations for each measure. So for example, random drift might actually indicate exploration. Drift that has certain characteristics might exhibit sort of collective exploration of the field rather than just sort of random copying. This is something Bentley actually recognizes in his paper and discusses briefly at the end. It's that it's not easy to put this sort of normative gloss over it. Stabilization might actually connote unproductive perseveration in the field. So a set of scholars have sort of just become fixated on a set of unproductive ideas. There's no way that these data can speak directly to the quality of that knowledge. And radical change in keyword use might actually indicate a period of creative transition in the field. So there's the possibility to take these measures and actually give them normative valuative glosses. But it's difficult to do so. So I think it's important, I have to hedge again, because this is going to be on YouTube, is that this is all kinds of statistical and linguistic caveats. So this is a very fun collaboration with Eric, but it's going to be a lot of work to really draw out these kinds of progress implications from what I'm going to show you. All right, you guys ready? How's that for a brief setup? Not so bad? Mildly interesting. We are a cognitive and information sciences group, by the way. So before you ask me, why is this cognitive science? Well, we're not in cognitive science. We're in cognitive and information science. So, so let's replicate the obvious. So Blaise Cronin, who's a famous scientometrics person, has these really interesting papers on comparing the sciences with the humanities with the social sciences. And what he found through very careful hand coding of journal articles. You can imagine going into the library, not this, some other library with lots of old journal articles, right? He can download, he's going through and counting the authors. He did this for hundreds of articles. And one paper of his I read, he claims in the paper he did it himself, so he didn't even have RAs to do it for him, he just did it himself. So what he found was it can easily be replicated with these kinds of data. So this is along the y-axis, this is linguistic inquiry, this is language. Along the y-axis is the average number of authors. And then along the x-axis, we have year. Now, I should have mentioned this linguistic inquiry. I kept it in there even though the data only started in 1970. So in general, linguists don't really collaborate, but you can see that there is a slight trend. They're starting to increase their authorship count. Now, if you compare that to the biological sciences, you can imagine what differences there will be, right? There we go. There's biological, so this is plant physiology and ecology. And they're very consistently rising over the decades. And here's philosophy. And this is, in fact, what Cronin found. So some of these philosophy journals, basically, you can't see the estimate of the lowest estimate. But the average philosophy paper has 1 on it. And I actually intended to get this before the talk today, but I told you everything was new, and I forgot. There's one paper that has 16 names on it in 1960 or 1954, I guess. And I have to go find that. But in general, these data allow you to even just have nice little descriptive numbers about these different journals and fields. So philosophy is like this. But philosophers, you guys knew this already, right? Widely known. Okay. But let's look at the turnover profile. So, oh, and I should note that Blaise Cronin has this really nice paper where he says, philosophers don't write papers together, but they talk all the time. So he calls it, philosophers actually engage in this active collaborative discourse, but it's actually, oh, you know what he found? That it's expressed in the acknowledgement sections of philosophy papers. So acknowledgements in philosophy papers have radically increased, but authorship has stayed flat, which is interesting anyway. Unfortunately, JSTOR does not give me acknowledgements, because that would be really awesome. So here is linguistics. This is the keyword turnover profile. So now, this is a lag along the x-axis. So time 0 is omitted, obviously, because the preservation count for lag 0 would be 1, because the keywords now, compared to now, are the same. But if you look, as you take an analysis outside of that lag of 0. You look at how many words are preserved. Linguistics exhibits this sort of drift pattern in general. Compare that to the biological sciences. There's a distinct increase. So looking in the future, there's this relative stabilization towards the future. And then here's philosophy. So there tends to be this sort of quadratic pattern, but it's also dropping in the later years as well. So in general, I'm not going to show you all the statistical models that we're still playing with, but linguistics actually doesn't really show any significant relationship with lag, whereas the biological sciences show positive increase. And in fact, at least 2 of these journals, or 3, actually shows significant decline in the lag. So in the future, you'd actually expect there to be a relative drop. Now, the only way you would get asymmetries in this measure is if the preservation rate's changing. And it's easy to show that just with formulae. So the only way you wouldn't get this sort of symmetric function is if over the years there's actually a change in the preservation rate. So here's the historical keyword turnover. Here's linguistics. Remember, linguistic typology starts in 1970. Linguistic inquiry, sorry. So it's relatively flat, stable. Here's biology. So there's a stabilization over historical time. So over the half century, you have a tendency to see an increase in the preservation of keywords. And then here's philosophy. So in fact, what we find is that in the same 3 journals that you saw before, in fact, these measures are related. That's why you saw an asymmetric function. Some of these, philosophy is actually showing this sort of drift away from stable preserved keyword usage, and it looks as if fewer and fewer over the keywords over the half century are preserved in subsequent volumes, whereas in the biological sciences, it's the opposite. All right, does this make some loose sense so far? Feeling okay? So it's kind of a depressing tale so far, but hold tight. We're going to go to the macro scale soon. You guys will be happy about it. This is all going to be on YouTube too. Yeah.
Is there any significance to the absolute value of the? So I know
yeah.
Some of the
Good question. Yeah, and actually that will come up. So if you just hold, because I'm actually going to, in the macro scale, I'm going to plot these functions on top of each other, and you'll see. That's a good question. But here's an issue. So buyer beware. Keyword islands in philosophy. Well, if you actually look at the journal count, the article counts, and so on. Compare linguistics to this field that has had revolutionary changes. I guess linguistics has. I don't know if you've had. Okay, who's the other linguist in the room? You got back. Yeah, okay, there you go. Linguistics has arguably experienced some revolutionary change, but I don't know if you would argue certain things would be analogous to, say, discovery and understanding of the structure of DNA and so on. But anyway, biology has gone through this incredible explosion of publication in that time period. So could it just be bigger keyword sample? And the short answer is yes. So when you control for just the number of types in a given year, actually all the effects just vanish. Some journals, for example, I think Philosophical Review actually started publishing in about 1950 fewer volumes every year. And actually that explains a lot of the change away. So we actually can't infer that keyword turnover rates are true turnover rates yet with further controls. So I want to say this sort of this portrayal I've just given you of these functions is telling and interesting, but there's more that we need to do, because in fact just the raw change that's taking place in these fields might by the nature of those changes just generate these keyword changes themselves. So what we wanted to do instead, so what we did is we looked at these individual journals. We didn't really look at the field of philosophy, or the field of linguistics, or the field of biological sciences. So what we wanted to do is to get a large sample of each of these fields on JSTOR, and then look at the same kinds of properties to see what holds. Because one argument that you could make about these levels is that the journal level of analysis might exhibit distinct dynamics from the community level. Journals change editorship. They change themes. They might change the thrust or goals of on the editorial board, which gets recycled, not recycled, but changed, turned over, right? So instead, what we can do is look at just the field itself at a more global level to see how it's changing. So I'm going to show you just a preliminary analysis of this macro global scale. So this is a different approach. You can do this with JSTOR, which is nice. I can say, look, I just want something from biology, and it will give you 30,000 random articles from that field in a given time range. And in fact, we grabbed from 1901 to 1999 to get the whole century. We had 30,000 articles from each field, so about 100,000 each. And each set had about 250,000 keywords. So this is a relatively large data set now, and this would stand in Katie Borner's sort of macro scale kind of analysis. Relatively smaller macro scale, but still a macro scale. Ready for the results? Okay, I'm going to show them on the same plot so we can look at the absolute value. So remember, these are the two functions. We're looking at this lag profile to see how, when you're comparing across different points in time, how the keywords are changing. And then here's just the raw change of keyword preservation over historical time over the century. Okay, here's the first result. Remember, I guess if you're seeing a tilt towards positive and if things are asymmetrical, that means there's likely a change historically, but it also would reflect that when you're looking forward, the field is actually preserving keywords. And in fact, all three show significant increase. In fact, philosophy shows the highest preservation than the other fields, actually. It's approximately the same number of keywords, same number of articles. Philosophy is a smaller field, so that could be why you have a higher preservation rate. But when you're looking forward, all the fields seem to be increasing. Then when you look at that historically, this is what you get. Now the interaction is actually robustly significant. So the biological sciences are indeed changing more quickly. They're starting to preserve their keywords more quickly than the other fields. But in general, philosophy, which has the shallowest slope, it's the oldest field, of course, it actually shows the highest rate of preservation. And that preservation rate is going up as well. So as the domain of knowledge is increasing, philosophy is actually reusing more of the concepts. That rate is increasing. So this is quite different from what we saw in the journal level analysis, which had the exact opposite pattern. And the argument that you could make is that in the Katie Borner sort of framework, if you're doing the journal level analysis would have potentially unveiled different kinds of dynamics that have different kinds of social implications about what's taking place in the journal. Whereas the macro scale analysis has implications for the broader field. All right, so this is obvious limitations. There are statistical issues that can't be easily resolved, like the trivial relationship between keyword and turnover rate. It's even true in the macro level of analysis as well, which we have to control for. Reliance on JSTOR can be troublesome as well. So, for example, because they do the IF TDF over the whole JSTOR, you get these ridiculous terms as keywords for philosophy articles, like philosopher, and keywords for linguistics articles, like language. So you probably need to do a follow-up term frequency, inverse document frequency, just for the fields themselves, so you can get what unique keyword is for these fields relative to for these articles relative to other philosophy articles or linguistics articles and so on. Also, JSTOR makes certain assumptions about the journals that we're extracting. So in the macro scale analysis, how do I know that? So for example, philosophy may have been going up, interestingly enough, because you can go and you can easily look at the journals. Journals are being created in philosophy, like applied philosophy. So for example, one prominent journal that shows distinct increase in keyword preservation and contribution is Business Ethics, which is considered it's actually categorized by JSTOR as a philosophy journal. So there are lots of concerns here. And of course, we need to analyze the keywords that are there to really know what's going on in the first place. So some famous scientometric analyses back in the day, one of the original scientometricians, Price, actually did some analyses on the half-life of concepts and sciences and so on. So we might be able to do like a half-life analysis of the keywords that compose these different fields to see what has the shallowest exponent and so on. So, but there are massive benefits to doing it this way as well. So Katie Borner has a recent paper, through a postdoc, I think, on just the fact that scientometrics is a scientific field, and you can subject it to all the really important aspects of scientific fields. So you can develop ideas about replicability, about data sharing, and so on. Even though these kinds of analyses are uncertain in any case, the ready availability of so much other data allows you to go replicate the kinds of patterns that we see. So it's exciting possibilities. And so coupling this with different kinds of qualitative analyses is really important as well. So Leesdorf is is a very widely cited and scientometrician who's been around for a while as well. And he has this nice statement at the end of one of his recent review articles. He says, the study of the communicative layer, which he seems to be a semiotician a little bit as well. So he invents keywords. Anyway, so the study of communicative layer opens up the philosophy of science to empirical operationalization, further refinement, and the possible rejection of hypotheses on statistical grounds. So we can quantify metaphilosophy, quantify an interest in understanding the way that knowledge is changing. So in this loosely adversarial collaboration, we do get some mixed patterns of results. And as I noted already, this interpretive gloss is one that we have to be careful with anyway. So I'm looking forward to continuing to interact with Eric and talk about nature of these keyword dynamics and get his take on them. So in the domain of metaphilosophy, there are these two opposing camps, right? These two sort of radical perspectives. And in fact, Tony Sciamaro has recently had an interesting paper, After the Philosophy of Mind, Replacing Scholasticism with Science, arguing that even the most prominent debates in philosophy of mind are really just empirical arguments now. We need to go do the experiments to figure them out. So this is the kind of thing Eric might actually say. But there's philosophical optimism as well. There's dynamic, multi-methodological approach to problems in need of some reconceptualization. Even Blaise Krona in the Science of Nutrition talks about this when he observes that because philosophers tend not to co-author with each other, that conceals this really rich discourse that's taking place in modern philosophy. And then Andrew Higgins, who's at Illinois, whom I mentioned, has this really nice recent paper in MetaPhilosophy, arguing that yes, there's this problem with certain branches of philosophy, but there are these other really exciting domains that we should look at. In fact, the one that they talk about is experimental philosophy, the experimentalist project and its benefits. And they detail all of these scientometric type benefits that would be derived from experimental philosophy. So methodological integration, topical integration with empirical findings and so on. So they have this wonderful description of this. But I guess I'm arguing that in the domain of metaphilosophy, it would be really important to use this kind of research strategy and develop explicit hypotheses that can be quantitatively checked using computational and quantitative methods. And so this is stuff that I've been doing with Deb Tollefson and Roger Cruz. So for example, the paper you guys read, we really wanted to explore the nature of joint action. Joint action is this perfect example of radically over-intellectualized philosophical theory among some in that camp. So Michael Bratman, the famous philosopher at Stanford, I believe, has this conceptual analysis of joint action, two people doing something together jointly. We intend to do this joint action, J, if and only if I intend that we J and you intend that we J. I intend that we J in accordance with and because of 1A, and meshing subplans of 1A. It's this really rich conceptual thing. Now, when I'm hanging out and I'm just playing music with Bobby, I don't know what Bobby's doing, but we're just there together, right? And Deb has this fun, she has this fun array of examples that just sort of violently resist this kind of conceptual characterization of joint action. For example, can you have joint action with a dog, your pet dog? Deb loves dogs. She thinks you can, right? Can you have joint action with your baby? Can robots engage in joint action? I mean, Deb actually articulates the fundamental evolutionary problem with Bratman's theory, because you would never understand how joint action would have emerged in the first place. So what we did in this paper is we wanted to see if people had intuitions about joint actions. And in fact, this was the result we did not want, but we found it anyway. We did this classic Eleanor Roche style similarity judgment, concept of categories kind of experiment. We just get people to make a series of Likert scale similarity ratings of different concepts, and you just get them to do a whole series of these. And then that allows you to get a dissimilarity matrix among those concepts, and then you can project them in lower dimensionality. And indeed, what you find is the first component, the first dimension of the multi-dimensional scaling solution is this jointness. So they rated these activities in this paper. The subjects rated these different activities, like talking on the phone, or reading a book, daydreaming, standing in line, driving with one's family. And you see this clear emerging jointness. So on this side, it's all solo activities, and on this side, it's all joint activities, which was actually in accord with Bratman and other theorists, actually. There seems to be this underlying interpretation of joint activities using this intentional sort of heuristic. But what we wanted to do more recently is that sort of gave them, obviously, a basis for strategizing. They could probably, because it was hard to tell in these kinds of experiments whether they can figure out what the dimensions are in the first place, and they use them while they're doing the task. So what we wanted to do is use more subtle kinds of techniques to tap into what people actually consider to be a joint activity. And so we've taken this sort of data-driven philosophy approach, and we've used crowdsourcing techniques like Amazon Mechanical Turk, where you can collect large volumes of data very easily. And also we've been harvesting from Twitter to look at, some of you may find this interesting, we can look at use of the first person singular and the first person plural, and we can just look at the semantic distribution and mention patterns that take place around those two very simple linguistic elements, one which invokes solo activity and the other which invokes social. And I don't have time to tell you about all these results, but the idea is we find that spontaneous recall over Amazon Mechanical Turk and mention on Twitter includes a large number of activities that can be regarded as shorn of much intentional structure, actually. So for example, going to sleep with your partner at night is where you actually mutually agree to completely lose the possibility of having intentions and consciousness together. you're off building a go-kart with your landlord, and I'm flying my unicorn. And we're lying there, right? And it's actually one of the most intimate, trusting moments of a person's life. I mean, if that's not joint in the absence of intention, then what is? And so we've actually found these kinds of things in the data, suggesting that Bratman's theories are, they're trying to find these conditions of necessity and sufficiency that are too brittle for the kinds of joint actions people actually conceptualize when they're just thinking about their data. So the argument here is experimental to data-driven philosophy. There are a lot of exciting possibilities for doing what we can do here in our group, taking ideas from experimentation and plenty of data and hanging out together with some big ideas about cognition and the mind, and trying to solve some long-standing puzzles, including even bridging high-level cultural stuff with the kinds of stuff in cognitive processing that we study in our labs as well. So that's the end.